When I was an undergraduate and a PhD here at Imperial College, one of my dreams was one day to come and give a lecture here. So not only am I giving a lecture, I'm giving a lecture in front of my favourite lecturer and in front of the administrator of NASA. Sorry, days like this don't come often. But what I want to do today is mainly talk about the power of dreams. Because dreams, we do it every night, but we forget about them. But dreams are so powerful, and they can influence our lives in so many different ways. So I want to talk about the power of dreams, but I also want to give you the sophisticated young person's guide to the universe. Now, as you know, I've got limited time, so I'm going to go a fair clip. But first of all, I want to start with telling you a bit about myself, because I am a space scientist. And just saying that gives me a real buzz, because my dream as a child was one day I wanted to go into space. I wanted to be like Charlie there and reach the stars. I wanted to go out and see what's out there. Now, that was my dream, and I haven't fulfilled my dream, but I think I'm doing the next best thing, because I'm building things that go into space. So I build machines like Aeolus. Aeolus is a satellite that's going to be launched in a few years' time, and it's doing something quite significant. It's helping us understand climate change. Now, climate change is probably one of the biggest challenges we're going to face in our lives, and your lives too. So just being part of something that can help us understand climate change gives me immense joy. And that's the power of science. It helps us understand things, and it helps us tackle problems. Now, Aeolus comes under the European Space Agency's Living Planet programme, and they have a series of satellites helping us understand climate change. And Aeolus is doing something quite strange, because it's trying to measure the wind speed through the Earth's atmosphere. Now, usually here on the surface of the Earth, we use windsocks and things like that to measure wind speed. But up in space, what we want to do is measure wind speed at different altitudes. And it does that by sending pulses of UV light into the atmosphere. Some of this light is, tiny bits of this light is reflected off particles moving under the influence of the wind. And because these particles are moving, the colour of the UV light changes by a tiny, tiny amount, and we detect that. And I was responsible for a team building the detectors that go in that satellite. So I was part of a group doing something quite amazing. So we have satellites that look down here on planet Earth, but we also have satellites that look deep into space. And I'm even more proud to be part of the James Webb Space Telescope. Now, the bit I was making for the James Webb Space Telescope was tiny, but I was managing a team of people making a tiny widget to go into this colossal machine. The James Webb Space Telescope is probably one of the most challenging space telescopes ever built, and it's been going through some challenging times as well in terms of budget. But it's due to be launched in 2018, and when it's launched, it's going to give us new vistas to the universe. Now, people here, has anyone heard of the Hubble Space Telescope? Yes, I thought so. The Hubble Space Telescope, have you seen some of the beautiful images we've got from the Hubble Space Telescope? And I'm going to show you some in my talk as well. Well, the James Webb will give us more amazing insight into the universe around us. And so to be just one of the scientists, and there's probably 3,000 scientists, 4,000 scientists across the world working on the James Webb. And just to be one of those scientists makes me very happy. This is a slight, because my dream was to become a space scientist, and that's just what I've been doing. But recently, this one came along. This is my daughter, Lauren. And so, so I have to put at least one picture of her in every talk I give. Actually, and often I bring her along on talks, but she's got a cold today, so I didn't bring her along. But, so as a scientist, life changes. And since Lauren's come along, my life has changed quite radically. And when Lauren was born, I wasn't very well for about 6 months afterwards. But all that time, I've been working. And so careers change. My dream job was to become a space scientist, an astronaut, but in the meantime, a space scientist. And Lauren's come along, and she's taken my life in a slightly different direction. And so now, what I've been doing is I've been doing things like this.
It's 6:30 a.m., an average day in an average house. But while we sleep, how many of us know our lives rely on extraordinary machines, keeping an eye on us from space? They influence time, tuning our clocks. As I settle down for breakfast, a satellite beams the signal to my television. At least 3 more make a live link to the other side of the world. and a further 4 allow the Met Office to forecast the British weather. These satellites aren't so surprising. You probably know about them already. But what about the hundreds you don't? Satellites that helped harvest the wheat for my husband's cereal, deliver his milk, or chose where to brew the coffee he's spilling. Others manage our water, overseeing flood control and surges of power in the national grid. Once in my car, everybody recognises a sat-nav. But what about the fuel I use? My lottery ticket? Even the train I catch? All increasingly depend on satellites. Trains, planes and automobiles? Shipping, cereals and flooding? It's not even 9 in the morning, and already I've used nearly 40 satellites.
So, that's the sort of thing I've been up to. So recently, I've been taking a sabbatical from space science and working as a television presenter, talking about science. That was one of my favourite programmes. It was talking about how satellites influence our lives. So a degree from Imperial can take you to many, many different places. And so far, I'm scratching the surface. There's many more places to go. But for my daughter Lauren, when I film, she comes with me. And but I have to keep on taking photographs of her as we visit different places. So this is her in Las Vegas. And this is her in Hollywood. Now, in a few years' time, she's going to say, "But Mum, I've never been to Hollywood." I'm saying, "Yes, you have. And I've got the photographic evidence." So careers can take all different shapes and sizes, and at the moment that's what I'm doing. But my real passion is science, and that's been a passion for a long time. Now, I say a degree and a PhD from Imperial can take you places. You can't get better than this. And this picture I still look at and I think, what's going on? I was a dyslexic kid growing up in London. How come I got to meet the Queen? And it just sort of blows my mind. And the reason I met the Queen is because of you guys. Because over the last 5 years, I've seen about 100,000 school kids. And I must admit, I'm knackered. but someone very kindly nominated me for an MBE, and I got to meet the Queen. And the thing is, I know what I'm like. I'm really clumsy. And I was terrified. Because, well, first of all, when you go and meet the Queen, what do you wear? So I went on a shopping frenzy. Every weekend, I was shopping. I bought 5 different dresses. I didn't wear them all at once. I narrowed it down to one. I got the silly hat. And the thing is, as it got closer and closer to the time, I was getting more and more nervous. As I say, I'm quite clumsy. And I had this horrible fear that I'd sort of try and curtsy in front of the Queen. I'd trip over, knock her out, and, headline in the newspapers, "Space scientist takes out Queen." And so by the time the day finally came, I was in quite a frenzy. But eventually, I was at Buckingham Palace, and they were wonderful there. They were so kind. But eventually they said, Dr. Maggie Adair-Pocock for services to science education. And I thought, that's me! No, calm, Maggie, calm. And I went up, and I sort of curtsied in front of the Queen, and then I bowed as well, just to make sure. And then I'm going to do the Queen's accent, which is probably treason. But the Queen said, "Sam, what do you do?" And I was so excited, I said, "I'm a space scientist!" And the Queen said, "Oh." And I think the Queen was shocked for 2 reasons. Firstly, I got my MBE for services to science education. So I think she assumed I was a teacher. It sort of naturally followed. But also I think she was slightly shocked because, just as Mark was saying earlier, I don't think I look like a space scientist. Usually when people think of a scientist, they think of someone who looks like this. Now, this is one of my heroes. He's a chap called Ernest Rutherford, and he did amazing experiments, really simple experiments, probing the heart of an atom. And he was quite clumsy like me, so we have a lot in common. But when usually people think of a scientist, they think of someone who looks like this. He's white, he's male, and he's looking very serious. Because most people expect scientists, because they think scientists have the brain the size of a small planet. And when you've got a brain that big, you've got no time for mucking about. You're thinking deep thoughts. So this is how people expect a scientist to look. Now, I've got another picture here. I think you'll recognise this chap. Albert Einstein, the grandfather of modern physics. Now, a few things to say about Albert Einstein. There are rumours, and I don't know if they're true, that Albert Einstein was dyslexic. Now, I'm dyslexic, so I'd love to believe it, but the idea of him, the maths that he did, if he was dyslexic, that's amazing. But another thing is that he didn't actually start speaking until he was 4 years old. So his parents probably thought he was a bit slow. That Albert is not going to amount to much, is he? I don't know why they got a Cockney accent. Anyway, they were German. But it just goes to show, even if you have a slow start, you can be the granddaddy or the grandmother of modern physics. So don't let a slow start put you off. But if you look at him here, he's white in his male again, but he's not looking quite so serious. And as we saw in the picture of Mark's earlier, this is another media portrayal of scientists, you know, the mad scientist, hell-bent on taking over the world, stroking a white cat. Mr. Bond, I'm going to take over the world and turn it into jam. Sorry, I do that a bit too well. But this is an image we have of scientists. So when I go out and see younger kids, I like to show them this picture. Because this is a picture of me and my husband on our wedding day. And I say, spot the scientist. Now, most of the younger kids will automatically go for my husband. But the fact is, both my husband and I, we did our degrees and our PhDs here at Imperial. And we don't have brains the size of small planets. We became scientists and engineers because we're inquisitive. We are the sort of people who asks why. There's a program, a television program I watch with my daughter called Tinga Tinga Tales, and it says, why? That's the question. If you are the sort of person that asks why all the time, then there's a scientist in you. And I think there's a bit of a scientist in all of us. And we need to harness that and utilize that, because science is so powerful and can do so much for us. So it's not about being a white male, it's not about having mad hair, although I do that well. It's about being inquisitive and wanting to find out things. Now, I like to show this picture, and usually if my daughter's with me, she says, iPad, because she watches the clangers on the iPad. Now, when people ask me why I became a space scientist, I hold these guys responsible. Because when I was 2 years old, I used to watch the clangers, but I used to watch it with almost a religious conviction. I thought the clangers were wonderful. And so I wanted to go out into space and meet the clangers. So I wanted to be an astronaut and travel to meet the clangers. But also, I was growing up in incredibly exciting times. I was born in the late 1960s, and I heard about Yuri Gagarin, the first person to leave the surface of the Earth and travel into space. To me, he must have been an incredibly brave man, because rockets weren't that reliable in those days. And so to leave the Earth, travel into space. And as David Southwood was saying, the fact that the Russians got there first blew people's minds away. But at the same time, people were so excited. We have our first astronaut. The science fiction had been talking about traveling to space, meeting the Martians, and at last we'd done it. We'd traveled into space. And then, of course, the Americans came along. You know, Neil Armstrong, one small step for man, one giant leap for mankind. Those are the immortal words he said as he stepped out on the moon. Now, these guys are true heroes. Charlie is a true hero because they had a dream, they had a passion, they had a desire to get out there. Now, if you put that into perspective, about 526 people have been out in space. And that's 525 people out of everybody that has ever lived. That is an amazingly small number of people that have been out there. So to get out into space, you need drive, you need passion, and you need the vision. And that's what these guys have. And I think we are incredibly honoured to have someone who's been out there with us today. So that was it for me. I got so excited about space. And the thing is, I didn't know how to go about getting into space. At first, when I was very young, I thought I was going to go and travel to Russia and learn Russian, because I thought Russians were putting women in space, so I thought that would be the way to go. But as a dyslexic, me learning Russian was just a bit of a laugh, so that wasn't going to happen. Then for a while, I thought I might join the Air Force, because most of the early astronauts were test pilots, so I thought, I'll go into the Air Force, become a test pilot, get into space that way. But that wasn't really going to happen either, and the uniform just really didn't suit me. So I had to find a way of getting into space. And so, just as David said, when I was a child, I used to travel and past the Science Museum, and I'd go in, and I'd see Imperial College. And I could almost hear the hum of brain activity coming out of Imperial. And I thought, one day, maybe I could go there. Now, as a child, I suffered from dyslexia, and for quite a bit of my life, I was put in remedial classes. So the idea of going to Imperial College was really just a pipe dream. But pipe dreams can come true. And when I got to Imperial, it was wonderful. I mean, my goal in life was to get to Imperial, and I got here, and it was wonderful. David was my first-year tutor, and with dyslexia, it's quite hard sometimes to do the mathematics, but they nursed me through it. I remember chasing Nobel laureates down through the corridors and saying, I can't understand my maths homework, and they'd help. So it was a nurturing environment. And also, you were interacting with people who were coming up with amazing theories. And so to just be in that environment, to meet these people, was a mind-boggling experience. So I stayed at Imperial, I did a degree in physics, and then I did a degree in mechanical engineering. This turned out to be the ultimate combination for my future career. But I always wanted to be a space scientist, but I didn't get there straight away. Careers can take sometimes wiggly-woggly paths. And so the first thing I did, I mentioned I studied mechanical engineering. I've got a small clip here that talks about engineering. Let's see if it's going to work. Or not. Whoops. Up. Okay. It was a Dilbert cartoon, but it's not showing. But it's talking about engineering and people's perception of engineering, which is quite interesting. But my first job was actually working for the MOD. Now, as a child, I was a pacifist. But when I actually left Imperial, I did my degree, I did my PhD. When I left Imperial, we were going through a credit crunch, so jobs were few and far between. And so I got my first job at the MOD. And I was a bit nervous about this. And so I went for the interview. They said, OK, yeah, you've got the job. So I said, well, what will I be doing? And they said, well, we can't tell you because you haven't signed the Official Secrets Act yet. And I said, how does that work? So I came on my first day, and what I was working on was a missile warning system. So what I was doing was actually trying to look cool outside aircraft. So I think I needed the dark glasses. I think I blew it there. But what I was doing was I was trying to understand what the plume of a missile looks like. And I needed to get this understanding because when there's a war on, let's say someone launches a land-to-air missile, it's heading for the aircraft. The pilot has a few seconds to respond, and he can respond. He can set off flares. So there's an aircraft, and there's a pyrotechnic flare. It looks a bit like the aircraft. The missile goes towards that, it blows up, everybody's safe. But the problem is if the pilot doesn't realize the missile's coming, his life is gone. He can be blown up. So what we were doing is we were trying to get an understanding what a missile plume looks like so we could get a missile warning system, which was a system that would sit on board the aircraft and automatically deploy flares immediately it detected a missile. The only problem is, if you've got a missile warning system, you need to get data about the missile itself. And so what I was doing was flying over some sands in Pendine in Wales. They had a missile tethered to the track, which would shoot down a 1.5 kilometre track. And then in an aircraft, we'd fly intercept courses above the missile and get data. Now, most people think of scientists and engineers as sitting in labs, tinkering with test tubes, playing on the computer. I've done all that. But I've also done the James Bond bit, hanging outside the back end of an aircraft, feeling the wind in my hair. A degree in physics and science can take you anywhere. And that was my first job, hanging out the back end of aircraft. So yes, it can be like James Bond. My first job. But this job really made me think about things, because my second job was actually working on anti-personnel mines. There were some horrible statistics about personnel mines. And I've actually visited Cambodia, where some of these landmines have been laid. And I've met kids who have had arms and legs blown off by landmines. So working in this area was very topical at the time, and it was felt critical. Something had to be done. But it also shows the power of science and the flip side of science. Science gives us the ability to view the universe, but it also gives us the ability to make landmines. There are engineers out there who have designed landmines, and these are crippling people. So one of my messages to you is, many people in this room, you might not want to become a scientist or an engineer, and that's fine. But it's important to have an understanding of science and engineering. Landmines are now banned across the world, and that is because of people like you made a decision that we don't want landmines anymore. So even if you don't want to be a scientist or an engineer, be aware of science, because it influences us in so many different ways, and you are the curators. You need to tell us what we should do and what we shouldn't. My favourite job of all, though, was working here. This is the Gemini telescope in South America. Now, actually, how old are you guys? 14, 15, that sort of age? Okay. Oh, okay. When I was about 14, one of the things I did is I made my own telescope. So I went to a telescope making class. first of all, what I did is, we were living in a council flat in Camden, and I bought a telescope from Argos, and I was so excited. I got my first telescope, got it home, pointed it up to the night sky, and it was horrible. It suffered from something called chromatic aberration, which meant when I looked at the moon, I had 3 different coloured moons. The optics just weren't very good, and I was so disappointed. I'd saved up my pocket money for quite a while. And so then I found an evening class, telescope making classes, and so I went along, and I was able to grind and polish my own telescope mirror. And the excitement the first night when I put my telescope together and I went outside, a clear night, pointed it up at the moon, and suddenly the craters of the moon leapt out of me and leapt out at me. And this is amazing because this is something I'd made with my own hands. So my telescope was about 150 millimeters across, about this big. My dream job was working on the Gemini telescope. Now, the Gemini telescope is in South America, and they build telescopes there because they can look into the heart of the Milky Way. And this is the telescope itself. I like to call it a cathedral to science, because it is truly beautiful, especially when they're getting ready to do a night's observation, because the sun is setting, and you get that purpley colour in the sky, and then they open up the dome, and the birds start flying around, and we get ready to do some observing. And the Gemini telescope, the heart of the Gemini telescope, is this primary mirror. Now, my telescope mirror was 150 millimeters across. This telescope mirror is 8 meters in diameter. Now, 8 meters is fantastic. 8 meters of light-gathering power. Now, with 8 meters, you can see deep into the universe and really get an understanding of what's out there. And what I was doing is, at UCL, I was building this. And this is BHROS, the bench-mounted high-resolution optical spectrograph. And it does something very interesting. It actually takes rainbows of stars. This is the output of BHROS. It's the spectrum. Now, by taking a spectrum of a star, you can tell so much about it. You can tell if it's moving towards you. You can tell if it's moving away from you. You can actually work out what chemical reactions are taking place in the heart of a star by taking its spectra. And so for me, this was a brilliant job. My dream as a child was to visit the stars. By building BHROS, I could look into the heart of a star billions of light years away. So it got me closer to my end goal. But one of the things that has always fascinated me is life in space. And I think Charlie can probably tell us a lot more about this. But this is a video of people living in space. And it just looks like fun. See, look, he's got a blob of Ribena there, and he's slurping it up. See, it looks quite messy as well, actually. Banana. Charlie, have you done this? And yeah, in space, everybody is a gymnast. So these are the reasons. As a child, I saw these images and I thought, yes, that's what I want to do. I want to go into space. But I want to give you a scenario. Now, I won't go into too much detail, but before I came and gave this talk, I decided I'd nip to the loo. Now, here on planet Earth, with normal gravitational forces at work, I sat on the loo. I won't go into too much detail. I did my stuff. It fell into the loo. I washed my hands. Ta-da! Now, you saw the chap with the Ribena. If you go to the loo in space, think of what's going to happen. That could all be pretty messy, couldn't it? Now, I won't go into too much detail, but now, the first guys that went into space, people like Yuri Gagarin and Neil Armstrong, they followed my daughter's example, and they wore nappies. They don't tell you that, but they wore nappies. But now, if you're going to stay on the International Space Station for a year, you get nappy rash. You don't want to wear a nappy for that long. So they've had to come up with a design for a space loo. Now, can anyone think, let's just put ourselves in the mindset of a space engineer. Can anyone think of what design we could come up for a space loo? What technology we could use for a space loo? Oh, sorry, I've got a hand at the back. What do you think? Sorry? Oh, no, just say it again, I just didn't hear you. Vacuum. Thank you, my good man. A vacuum. Sounds like an ideal scenario. Now, what I'm going to do is give you a demonstration of how to go to the limit of space. Now, I've never done this in front of an astronaut before, so this could be embarrassing. Now, this is a picture of the loo on the International Space Station. And what I'm going to do is give you a demonstration of how it is done. Okay? Let me step into a wide space. Now, first of all, I'm on the International Space Station. This is my dream come true. I've squirted my Ribena, I've spun my banana, and I've done some somersaults. And suddenly, ooh, I need to go to the loo. So first of all, I go over to the cubicle and I shut the door firmly, because this could be messy. Okay, so next time I float over and I sit on the loo. But the problem is, I'm in a zero gravity environment. So halfway through, I float off. So the first thing you do is you see those white bars, you use those to strap yourself into place. Now I'm going nowhere. Okay, so I'm strapped into place. Next, you can see there's sort of gloves and there's a suction pump just at the side. As you said, you use a vacuum. So you apply the suction pump to the right sort of places, you do your stuff, it gets sucked away, you wipe everything down and ta-da! I've been to the loo in space. But as you see, it's much, much more complicated than doing a very simple task here on Earth. So life in space is fun, but it's quite complicated. Now, I would talk about recycling of the water, and I should ask John, in fact, okay, I'm going to do this. This is a 1 litre bottle of water. Getting 1 litre of water, 1 litre of water weighs 1 kilogram. Getting 1 kilogram of stuff into space costs, depending on the oil price, about £15,000 just for 1 kilogram of stuff. Now, so you can imagine getting me, I had a big breakfast, getting me into space is going to cost a lot more. So when someone's done their stuff, what do you think happens to the waste product? you guys can see where I'm going with this. I knew you were a bright audience. So effectively, with the water, they take it and they filter it, and they filter it, and they filter it, and they filter it one more time, I understand, and then it goes back into the water supply. Now, Charlie, is this true? Is this true? And Charlie, how does the water taste? It tastes good. Hey, he has to say that. Okay. So that is life in space. Now, my problem is, my dream is still, I want to go into space. But the thing is, I'm getting a bit old. Actually, a few years ago, the European Space Agency applied for astronauts. I've been waiting all my life to be an astronaut, and finally, they had a call. We need astronauts. And so I applied, but I didn't get in. So what I'm thinking now is I need to come up with a new way of getting into space. And so I reckon if I become big enough in the media and combine that with my space career, this might be my way of getting into space. And so, has anyone heard of the television program Big Brother? You're a good audience. Most people say, no, I've never seen Big Brother. No, I don't watch that. So Big Brother is, for those of you who aren't familiar with it, Big Brother is a television series where they take 10 people, they put them in a house, they squabble, they argue, and then people get evicted and they have to leave the house. But I think Big Brother's getting boring. It's on Channel 5 now, and I think it's getting boring. So I think we need to give it a new lease of life. So I want Big Brother meets interplanetary travel. My idea is we have a Big Brother spaceship going to Mars. And on that Big Brother spaceship, we put 10 passengers from all over the world. And those 10 passengers, they're selected from all around the world, because I don't want it to be like your sort of moon landings where an American flag is planted on Mars. If we go to Mars, we go to Mars for everybody. And if we plant any flag, it's a flag of the United Nations. So we select people from around the world, and just like Big Brother, we have real-time coverage. Cameras all over the place, maybe not in the loos, we've discussed that, that's too messy, but cameras everywhere else. But as you can imagine, there's some challenges associated with this, and the biggest challenge of all is the cost. Because the cost of a mission to Mars is incredibly expensive. You have to, if it costs £15,000 to put 1 kilogram into space, think 10 people, the food they need for a journey for 8 months, it's going to be incredibly expensive. But I've got a solution to that, and it's selling the television rights. Because they did this for football a few years ago. They sold the international rights to football, and they got about £5 billion for football. I reckon this could be a lot more interesting. So that's one of the ways of covering the costs. But there's another big problem with the Big Brother spaceship, and that's eviction. Because if you imagine you're on the Big Brother spaceship, you're traveling through space, and suddenly, Dr. Maggie Adair and Pocock, please make your way to the airlock. You've been evicted from the Big Brother spaceship. Have a nice day. That's just not going to work. It's not that sort of program. Although some people have been volunteering politicians to go on. So I reckon I had to come up with a new solution. And my solution is this. The 2 people who win the competition come back to Earth. The other 8 people live out the rest of their days on the Martian surface. And this sounds like a crazy dream, but it's becoming more of a reality. We've found water on Mars. We could actually have enough equipment that people could live on Mars. So this is now my retirement plan. And I had the opportunity to make this into a film a few years ago. Oh, none of my film clips are working. Anyway, it was a film clip of me on the Big Brother spaceship just before we touched down on Mars. And I've nominated myself for eviction from the spaceship because I want to retire to Mars. Okay, I think we're lucky people. We live in incredibly exciting times. I mean, last week, they were talking about discovering the Higgs boson. Some of the work in finding the Higgs boson was done here at Imperial College. We are clawing to our understanding of the universe. There are areas, we understand now the human genome. We know our DNA. The implication of that is amazing. The drugs that we will be able to come up with and how that will extend our life in the future is amazing. There is an area of biology, which I only just discovered recently, called synthetic biology, where people are actually able to take strands of DNA and make living cells. The idea that we can make living cells, to me, blows my mind. And more in my field, exoplanets. Astronomy is discovering planets going around other stars. We live in exciting times. We've got about 800 exoplanets we've discovered now. So we live in the solar system. Our local star is the sun, but you can go out and look at other stars and other planets going around them. In terms of searching for life, we are making amazing strides in doing just that. But ideas evolve. 400 years ago, we thought that the Earth was the center of the universe. We are Earth. Everything revolves around us. The sun comes up, the sun goes down. Everything revolves around us. But then people use technology, people use telescopes, and people like Copernicus came up with the idea, no, that's not right. By making observations, we realize that the Earth isn't the center of the universe, but we think the sun is. That makes a lot more sense. And now, we're using even more incredible technology to discover what's out there. Some people say to me sometimes, why do we build space instrumentation? We have, amazing telescopes now. And the Gemini telescope was 8 meters. The European community has just given permission to make the ELT. Now, telescopes come in different shapes and sizes. Currently, the biggest telescope in the world is the VLT, the Very Large Telescope. I know, scientists can be a bit boring now, but we just got a permission to make the ELT, which is the Extremely Large Telescope. And in the future, maybe 20, 30 years down the line, we might be able to make the OWL, which stands for the Overwhelmingly Large Telescope. But we have these amazing telescopes here on the Earth. Why do we put things in space? But the answer is simple. If you look at this picture here, it shows the electromagnetic spectrum going from radio waves to gamma rays, and it shows the atmosphere. And it shows that certain parts of the electromagnetic spectrum can't penetrate the Earth's atmosphere. And so if we don't go up into space, we can't actually detect those different parts of the electromagnetic spectrum. And why is this important? Well, I want to give you an example of a picture by Van Gogh called Starry Night. If you break Starry Night down into its component colours, it's quite hard to see what's going on. So we just get the blue colours here. Okay, we can see some swirls, but it's hard to see what's happening. Let's look at the yellows. We get a bit more of the picture. Let's look at sort of the greens and sort of a bit of red there. We're getting a bit more of a picture. But it's not until we put all those different colours together that we get the complete picture. And it's exactly the same for looking out into the universe. This shows different wavelengths that we can look at our galaxy in. And you can see, if you look at the optical, which is here, oops, where's my mouse? If you look at the optical, it's here. You can see the clouds of dust, which we can't just penetrate with visible light. But if you look at the same thing with the infrared light, infrared passes through that dust, so we can see what's happening. So that is the need for space telescopes, so we can actually get the complete picture of the universe. And that picture is giving us better understanding of what's out there. So we now know that we live in a galaxy that contains approximately 200 billion stars. Now, 200 billion stars is quite a mind-boggling number, especially when you consider that each one of those stars is a sun like our sun, so potentially has planets going around it. It means that in our galaxy, there must be billions and billions and billions of planets. And so now we're actually detecting some of these planets and trying to work out what sort of planets they are. And we're also trying to look for signs of life. And by the time we make something like the OWL, the Overwhelmingly Large Telescope, we might be able to get enough light passing through an atmosphere of an exoplanet that we can actually look for the fingerprints of life. So we now know that we are a fairly insignificant star in one of the spiral arms of this galaxy. one of 200 billion other stars. But we can do even more than that now. This is looking at the edge of the universe. It's a piece of, this one does work. This is a piece of footage called the Hubble Deep Field. And when the Hubble was first launched, it had a few, very embarrassingly, it had some optical difficulties. And these were corrected. And then the Hubble was able to take some fantastic images, and I think you've seen some of these images. But one of my favorite images is this one, and it's called the Hubble Deep Field. And what the Hubble Space Telescope did is it looked at a tiny piece of sky. It's about 1 centimetre square at arm's length. It looked at a tiny piece of sky, and it stared at it for 6 whole days. And it did this to get a very, very long exposure. It's just like with your camera. If you make your exposure longer, you get more light coming in, and you can see very, very dim objects. And so this is just what they did. They did this exposure, and this is what they saw. And they saw, okay, it's not empty space. There's actually something out there. And then when we look more closely, we realize that each one of those points of light we see is not a star. Each one of those points of light is a galaxy. So what we thought was empty space was actually full of galaxies. And so what we were able to do as scientists is we were able to square up, take that tiny piece of space and square up for the whole of the universe and work out how many galaxies we think are in the whole of the universe. And our galaxy, the Milky Way, 200 billion stars. In the whole of the universe, we think that there are approximately 100 billion galaxies. Now, I'm an insomniac, and when I can't sleep at night, I just try and contemplate this. Think about how many stars in our galaxy, how many planets, how many galaxies in the whole universe, and it boggles my mind, and I usually drift off. So we live in an amazing universe, and technology is helping us discover that universe. And it's funny because some people, they see this, and they hear those numbers, and they feel sort of small and insignificant. And I must admit, it doesn't make me feel that way. When I see all this, I just feel it's wonderful to be part of something truly amazing out there. And I want to find out more and more about it. But it also makes me think that, what are we doing? We are here on this planet. We have short lives, and yet we have wars, we squabble, race, religion, anything, we find time to argue about it. And on the scale of the universe, it's like ants squabbling on a leaf, but it's even smaller than that. So why do we do it? So my message is, build spaceships, not war machines, because it makes a whole lot more sense. And I just feel very happy to be part of something so glorious. Thank you very much for listening.
Thank you. Thank you very much, Maggie. I'm sure you'll agree that was very inspiring. And before we move on to our next speaker, we've got a musical interlude by Beth Chapman, a former Grammy-nominated Beth Chapman. And she's done a lot of work collaborating with NASA on events like this. And she's recently put together a children's album called The Mighty Sky, which is clearly an ode to what's out there. So we're now going to introduce Beth Chapman. Thank you.
Thank you. I don't know if you hear that funny sound up there. Might just be my monitor. It's so amazing to be here, and Maggie, you're such an inspiration. I wrote down about 5 titles to songs I'm going to write from what you just said. In the Heart of a Star. What a great title for a song. So if you want to become a songwriter as well, you know, just you got an amazing, amazing creative mind. Anyway, my name is Beth Nielsen Chapman, and I am so excited to be here and going to do a couple of songs for you from a CD called The Mighty Sky, which is coming out this September. And I've made my living as a songwriter, writing some songs for other artists and making records on my own. But the most fun I've ever had writing songs was working with Rocky Alvey, who wrote all the lyrics to these songs about astronomy. And so I'm going to do a little medley of a couple of songs, and then we're going to do a premiere viewing of a video on another song called The Moon. And this one here is called The Neutron Star, and it's we actually used the recording of a star imploding, which was discovered by Jocelyn Bell Burnell, a Scottish scientist. And It was the most amazing sound. It's a recording. It sounds like Wipeout. It's going. It's a knocking sound. So we decided to write the music around it, and so you'll have to imagine that sound in your head. And it's called The Rockin' Little Neutron Star. Listen up, children, got a story to tell. There's music out in space ringing clear as a bell. I promise that it's true, though it's hard to believe. Get your radio tuned to the frequencies. Here goes. Her career was finished and her bright days were done. She'd been up on the stage, she'd outshine the sun. All the other stars said it's time to move over. Man, we got an eyeful when she went supernova. Yeah! She's a neutron star. She spins like a top, a little pulsar. Man, she knows how to rock. She'd been a little bigger, would have been a black hole. We could hear a rhythm on the radio. She's been a heavyweight since the moment of birth. A spoonful weighs as much as a mountain of earth. 1,000 years ago, man, she lit up the sky. She's gonna be around till the universe dies. Ooh, ooh. She's a neutron star. She spins like a top, a little pulsar, man, she knows how to rock. She'd been a little bigger, would have been a black hole. We could hear her rhythm on the radio. This is the pulsar, the constellation of Vela, that was formed when the first supernova took place 10,000 years ago. If the sun were the size of a basketball, that would make the solar system small. The earth would only be a grain of sand. You could hold the planets with one hand. How far away would Pluto be if we started sailing that cosmic sea? A hop, skip, jump gets us all to Mars. We could fly a plane to the nearest stars. Make small things big, make big things small. Make the sun a grape or a basketball. The greatest journey you'll ever find is the one that starts inside your mind. If atoms were the size of a red balloon, your fingers would stretch from the earth to the moon. You could make a necklace out of Saturn's rings. Baby, we be talking about some far out bling. How far is far, how wide is wide? How big is the boundary of the largest star? How deep is deep, how small is small? On your mind's eye can see it all. Make small things big, make big things small. Make the sun a grape or a basketball. The greatest journey you'll ever find is the one that starts inside your mind. The greatest journey you'll ever find is the one that starts inside your mind. Yeah, 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 yeah. How far is void now? How far is far? Yeah, 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 yeah. How deep is deep now? How small is small? Yeah, 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 yeah. Tighten up. Thank you so much. So I'm gonna need you to start that thing for me there, Adam. This is the world premiere of a video that we did on a song called "The Moon," And this is your job. Your job is to clap along. And when it starts, you guys are going to be my clapping section here. And I worked with some great musicians on this record. And the guy singing the bass on this is Arnold McCuller, who goes out and sings for the past 30 years with James Taylor, among other wonderful places he's sung. So anyway, this is my face. My daughter-in-law and my son helped create this video. And my daughter-in-law is a great painter, so she painted my face like Earth, and we got this little boy to be the moon and this other little girl to be the sun. So this is really kind of fun, crazy, cheesy, but you know, it's really fun. And you guys are the first ones to see the final one. So this is called The Moon. And take it away. I'm singing along with it, and y'all are going to be clapping. And oh, don't do it. Oh, here we go with the technology. We did get this during the sound check. We need there we go. Moon, moon, ba ba moon, 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 ba. Oh the moon, oh the moon, oh the big round moon. I love to watch the beautiful moon. It's a wonder in the sky from July through June. There's nothing quite as lovely as the moon, the moon. There's nothing quite as lovely as the moon. Circle in the earth every 29 days, reflecting the sun's pure light. Technology has made us... All right, here we go. How about that for a glamorous shot? Why did everything change, oh Lord? Well, this isn't nearly as complicated as going to the loo in space, though. Can you just hit the play thing? I know. Okay, it's going to start again, and this time it'll be right. Moon, moon, ba, ba, moon, 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 ba. Oh, the moon, oh, the moon, oh, the big round moon. I love to watch the beautiful moon. It's a wonder in the sky from July through June. There's nothing quite as lovely as the moon, the moon. There's nothing quite as lovely as the moon. Circle in the earth every 29 days, reflecting the sun's pure light. In a new and a full and a crescent phase, we see a different show every night. We see a different show every night. Well, the moon and the sun pull the surface of the earth, and sea to rise. That, my friends, for whatever it's worth, is why we experience the tides, why we experience the tides. The moon looks big at rise and set, and smaller when it climbs up high. It's the very same thing if you measure it. The moon is good at fooling our eyes. The moon is good at fooling our eyes. Oh, the moon, oh, the moon, oh, the big round moon. I love to watch the beautiful moon. It's a wonder in the sky from July through June. There's nothing quite as lovely as the moon. No, there's nothing like. There's nothing quite as lovely as the moon. No, there's nothing like. There's nothing quite as lovely as the moon. No, there's nothing like the moon. Nothing quite as lovely as the moon.
Wonderful. 1-1. Okay. Not sure if this is working. Oh, it is working now. So, once again, let's put our hands together for Beth Chapman. That was an excellent musical interlude. Now for the main event, if we can call it that. I'm delighted to introduce, well, in fact, I could tell you many things about the next speaker. I could tell you that he was a former Army general. I could tell you that he flew fighter pilots during Vietnam. I could tell you that he was an astronaut. But I asked him himself, how would he like to be introduced? And I'm going to introduce him how he would like to be introduced. I would now like to welcome the administrator for NASA, who also has 3 grandchildren. So can I welcome Charles Bolden?
Thank you very much.
Well done.
Excellent. Thank you all very much. I have some slides up here that I'm going to use because I don't want you to get bored. So if you get bored with what I'm saying, don't worry about it. Just keep watching the slides and somebody yell out next or something like that. I am so pleased to be here. Maggie, I just can't thank you enough. It was truly inspirational hearing your story. And Beth, it's always good to hear your music. And I want to thank the university and the American Embassy for putting this on today. This is your time, okay? It's your time. You will really help me if you ask questions. So I have 2 rules, only 2 rules. Rule number 1, you can ask questions anytime you want. There is no formal question and answer period. Rule number 2, there is no dumb question. You can't think of a question that should not be asked. So just ask the questions and let's talk a little bit. I'm going to do some formal things. I just want to talk a little bit about who NASA is, what are we, and what do we do. And Maggie's talked about a lot of it, but in NASA we have 3 major directorates. One is the Science Mission Directorate. The other one is the Aeronautics Mission Directorate, and they do kind of naturally what it sounds like. And then the third, and actually the largest, is the Human Exploration and Operations Mission Directorate. To support them, we have a Technology Development Office under the Office of Chief Technologist, and we do a lot of other things. But those are the 3 major things we do. In the area of science, we have 4 different divisions or departments. We have planetary science. That's who we are. That's what is Earth all about. What are other planets about? What about Mars or Venus or Jupiter or others? So we do planetary science. We do Earth science. That's our environment. Maggie talked about it. You know, climate change. It is happening. We don't know why. We don't know what. But we know things are not the way they used to be. And so what NASA tries to do is to develop instruments that scientists and experimenters can use to help answer some of those questions about what's really going on, what's causing it all. Hubble is from the area of astrophysics and planetary science, as a matter of fact. But this image up in the top right is from the Hubble Space Telescope. Absolutely incredible observatory. It's called a telescope, but it's not. It's an observatory. It's an observatory without people in it because it brings all of its data to Earth, and through the Space Telescope Science Institute outside of Baltimore, Maryland, scientists around the world are able to take the data that comes from Hubble. Hubble works a different kind of way. You know, it's not like a normal telescope. You go look through a sight piece and you can see pictures and stuff. Hubble gets its images, converts them into electrons, sends radio signals down to Earth through a series of satellites. They get reprocessed when they get to the Hubble Space Telescope Science Institute, and they go all over the world for people to use, for scientists, engineers, astronomers, anybody. We also have, and I'm going to ask you for help. What's the bottom right? What's the science of the sun? Anybody help? Yes. What is it? That you got the big initial is right. It starts with an H. No. Heliophysics is the study of the sun. Today, you know, the sun used to be kind of, nobody cared about it, to be quite honest, until very recently. How many of you have a cell phone right now? You know what happens when the sun gets really, really active? it sends energy out. And of late, everybody's become interested in space weather. All space weather is stuff that's coming from the sun, coming from other planets, trying to get into our atmosphere. Remember when Maggie showed you the picture of the atmosphere? Earth has a number of different shells around it that protect us. The primary one is the atmosphere, but there's another one called the magnetosphere. Anybody ever hear of the magnetosphere? Okay. Have the teachers in here. I'm not going to ask the teachers, but okay. Have any of you in your class done the experiment yet where you put metal filings on a piece of paper or on a glass, a piece of glass, and then you take, everybody know what a bar magnet is? You know, North and South Pole? Have you done the experiment where you put the bar magnet under the paper or under the glass? What happened to the filings? Where do they go? What do they look like? Yes? Ah, like a forward and a backward C. That's Earth. Okay? And the two places where the forward and backward C starts, those are the poles. Those are the magnetic poles of Earth. And so it's the magnetic shield around Earth that protects us. And you saw it in one of Maggie's images where she showed that stuff like infrared energy, X-rays, gamma rays, other kinds of things, some of them get shielded from us, from human beings, and protect us, keep us alive. But up where the poles are, just like you saw with the little bar magnet, everything comes into the points of the poles. Earth is the same way, the North Pole, South Pole, so we get to see incredible shows there these times of our lives because the sun is reaching what we call solar maximum, where it's at its maximum peak of energy, and the rays of energy or the particles of energy that come from the sun are beginning to bombard our magnetosphere and our Earth like never before. And so some of that energy is sneaking in at the poles, and you're seeing incredible forms of energy, light, that we call the aurora. In the northern hemisphere, it's called the aurora borealis. In the southern hemisphere, it's called the aurora australis. So, you know, we used to not pay a lot of attention to the sun, but it's amazing how people are getting interested in it, because if we really get hit by a big wave of energy from the sun and it doesn't get shielded from us, forget your cell phone, forget GPS, forget television, forget all those kinds of things, because they're just going to be disrupted. And it will happen. It happens occasionally, and you get a little, you know, a little static and all that, but it's going to happen. This is one of our satellites that's en route to Jupiter right now, called Juno. Juno is absolutely spectacular. Most satellites that go to distant planets have a power source on it, a nuclear power source. Why? Why not? What's different about this one? Anybody know? On its way to Jupiter. What looks different? What about the three things sticking out there? What do you think they are? Yes. They're solar panels. We've never sent a satellite as far away as Jupiter with solar panels before, but because up until now, our technology did not give us solar cells that could actually take the very weak energy from the sun that you find all the way out at Jupiter and produce enough electricity to run the satellite. Juno is different. It has very new technology, solar cells. We believe that when it gets to Jupiter and starts to orbit the planet, it's going to be taking energy from the sun and converting it into electricity through the solar cells. So this is quite a revolutionary experiment. These are among my favorites. They're called Grail. They're twin satellites. Some elementary school students in the United States actually gave them names. Anybody know what the names of the two Grail spacecraft are? They're Ebb and Flow. Now, where in the world did they get those names? Ebb and Flow. Why would they say that? Ebb and flow. What about tides? How do tides operate? They ebb and they flow. They come in, they go out, they go in, they go out. Question right there. Ask it.
Does the moon make the waves go?
Does the moon
Make the waves?
Oh, does it make the waves go? We believe that because the moon has its own gravitational field and it affects Earth. And what we think, one of the largest ways we think it affects Earth is in the tidal movement. We think that, you know, it's actually the the gravitational pull of the moon that causes the waves to come in when the tide comes in, allows them to go out when the tide goes out. So it does have some effect. Ebb and flow have one big purpose: to map the gravitational field of the moon. Because since it has such an effect on Earth, we want to understand it a little bit better. So these two satellites are flying around the moon in trail, is what we call it. One of them has a laser that's looking at the other one, and using GPS, it can very, very effectively tell what height above the moon's surface the forward satellite is. And the front one can look back at the back one and do the same thing. So as they go around the moon, their altitude changes very slightly depending on how strong or how weak the gravitational field of the moon gets. So scientists on Earth can look at the data, and we have now completely mapped the gravitational field of the moon. What we've also found from ebb and flow is that we're able to scientifically now look into the core of the moon itself and tell a lot about how the moon is made up and what's important about it, because, you know, it may tell us some things about Earth. So a lot of these things, most of what NASA does is trying to find ways to make life better for us here on Earth. I'm going to tell you about this. This is incredible. You know, Maggie talked about her plan to go to Mars. I'm with her. I want to do something. On the 6th of August, someplace, depends on where you are, 6th or the 5th, we have a rover. It's the largest rover ever sent to a planet. And it's called Curiosity. It's the Mars Science Laboratory. It's on its way to Mars now. We launched it Thanksgiving weekend back last year. It's speeding, making its 8-month trip to Mars on the 6th of August. The way my people describe it at NASA is, we'll go through 7 minutes of terror. The scientists call it 7 minutes of terror because Mars is so far away that it takes about 7 minutes for the radio signals to get there and then come back to us. So something will have happened to Curiosity, but we won't know it for 7 minutes. So the scientists are going to be sitting at the Jet Propulsion Laboratory and other places all around the world, and their stomachs are going to be churning. Because at the appointed time, they're going to go, and then 7 minutes later, they'll either go, "You!" or they'll go, because we have this incredibly elaborate way to get Curiosity onto the surface of Mars. It goes flying through the Martian atmosphere, which is not very thick, not like the atmosphere of Earth at all. We don't know a lot about it, so we've had to make some guesses. And even now, the scientists are still trying to guess what they think the Martian atmosphere is going to be like, because it's going to have a big heat shield that will slow it down a little bit. Then when it gets to a certain height, big parachute's going to pop out. It's going to slow it a little bit more. And then finally, as it gets a couple of hundred feet, a couple of hundred meters above the surface of Mars, these rocket engines are going to fire and slow it ever so much until it stops. And then they've got literally minutes, very few minutes, for a crane, a cable, to lower the Curiosity rover to the surface of Mars. It's not going to go boom and bounce around like the other Mars rovers did. It's going to go very precisely down to the surface of Mars at the foot of a mountain called in a crater called Gale Crater, and then it's going to start its journey across the Martian surface. It can be there for 10 years, 50 years, we don't know. But among the things that are going to be incredibly unique about the Mars Science Laboratory, remember Maggie talked about a spectrum? Well, it has an instrument called a spectrograph that's a part of the rover. So as it goes around, it has an arm. It's going to take samples from the Martian surface, put them in the spectrograph. Some of them will be heated up, and so that the scientists can look at the spectrum of what's being collected, and we'll be able to tell, okay, is it iron? Is it copper? Is it life? And the big question, the big reason for doing all this is trying to answer the two universal questions since humankind have been around. Are we alone? And is there life? And so this may be the first opportunity for us to find out whether there has ever been life on Mars or whether there's still potential to sustain life on Mars. What's incredibly important is we know there's lots of ice. We think there's tons of water under the surface, all of which point to the possibility of life on Mars. Cameras, you're going to see high-def 3D color images near real time from the planet's surface. Never been done before. If any of you go to our NASA website, www.nasa.gov, and look at the news part, you'll see this week we've been showing images that have been collected by Opportunity, the Opportunity rover, for years now. It was intended to be there for like 60 days. It's been operating for years. It's a little rover just kind of crawling around the planet. The images from Opportunity are mind-boggling. Just think about that, as Maggie said about JWST, the James Webb Space Telescope, 100 times better than Hubble. This is going to be multiple times better than what we've seen on Opportunity. So look at the images from Opportunity and just use your imagination. 3D, high-definition color images from the surface of Mars. Going to be absolutely incredible. August 5th and 6th, I forget which day it is for you, probably the 6th, be peeled to the TV because we're going to be showing it. Here's human exploration. The hallmark of human exploration, now that we've finally retired the shuttle. Shuttle had an incredible 30-year lifetime. I was blessed to have flown on the shuttle 4 times to space. I flew Columbia, Discovery twice, and Atlantis once. People ask, are they different? You know, can you tell the difference in spacecraft? Not really. Columbia, because it was the oldest vehicle before we lost it, was the heaviest and the most sturdy, if you will. Endeavour, which is the baby of the fleet, was a lot lighter than Columbia. They had taken a lot of what we call the structure out, so it didn't have as much metal in it. So actually, when I flew Atlantis, you could hear things on Atlantis during ascent that you didn't hear on Columbia. It doesn't make any difference what vehicle it is. You know, you're laying on your back, you're there ready to go, and you can hear the countdown, 5, 4, 3, 2, 1. And at the 5-second point, the thing goes, 3 main engines just start, and the shuttle kind of goes like it's going to tip over. Oh, question back there. Yell it. Yell it.
Okay,
Was there a mic?
I have a mic, yes.
Yes.
How would you describe your experience when you first time in space?
Oh, how do you describe the experience
your
the first time?
Yeah, your first
Oh, it was
experience.
awesome. I mean, I wish I had a word, an appropriate word. It was awesome. It was exhilarating. It was exciting. It was actually, you know, the word is not
scared?
fear,
Oh, okay.
but you're anxious. You're anxious to do the right things. And like I said, when the main engine starts, the shuttle shakes, you can literally feel it. You can feel it move. It does what we call the twang. It rocks that way, then it comes back to straight up. In those 6 seconds, everything's checked out by the computers, and then the 2 solid rocket boosters ignite, and boom, and you just feel the whole thing go. And you lift off very gently. It's about a G1/2. It's not a lot, because you've got a 7 million pound vehicle, you know, that's being lifted, that's 4 million pound vehicle that's being lifted by 7 million pounds of force. So there's not a lot of G. It's about a G1/2. Getting to space takes 8.5 minutes. When you get there, in my experience, my very first time, you know, you raise your seat, you look out the front window, and then just, it's awe-inspiring. You go around Earth once every 90 minutes. So every 45 minutes, the sun rises and then sets, and then rises and then sets. So 16 times every normal Earth day, you see the sun rise and set. And it's just absolutely mind-boggling. You know, the way that we launch out of the United States, out of the Kennedy Space Center, we kind of fly up the east coast of the United States, and because Earth is tilted on its axis, we essentially launch due east, but then we turn a little bit to go, because we want to go up to a higher latitude, because that's where the International Space Station is. So when you get there, it seems like you're coming down across the United Kingdom. And you look down, and on my first flight, I could see the UK, and I looked ahead, and it looked like a big island. I mean, a big, big island. That island was the continent of Africa. And it so awed me because, you know, as an African American, my heritage is from somewhere in Africa. And I had spent a lot of time trying to get ready for my flight, studying African geography so that I could look and say, okay, there's Nigeria, there's Namibia, there's this country, that country. I looked and nothing. I mean, it's all one huge continent. I literally cried. I had tears coming down my eyes. I was just, that's how awestruck I was. So it's an awesome feeling. And Maggie mentioned something about the fact that we're not insignificant. We're really important. We are. But the feeling you get from that vantage point is total insignificance. You know, you look down, you cannot tell that humans are here on Earth. You see long linear features like roads and bridges and stuff. Buildings generally don't show up in the daytime. You can see stuff at night because it's all lit up. But you just don't see any evidence that humans are here. Question right there. What did it feel like? Oh, did I fear for my life? No, I didn't. And that's what I was trying to hint at. We had trained for years. And all of us on my crew were incredibly confident that we knew what to do. And even more important, we knew that there were thousands of people on Earth who were keeping watch over everything. If anything happened to the shuttle, they would know it long before we did. They'd either be able to take some action to try to keep anything from happening or get word to us so we could reconfigure if we had to or do something. Yeah. But I don't think, I wasn't afraid. I was just apprehensive about doing all the right things. Yes?
When you were younger, did you want this role in life?
Ooh, I never dreamed of going to space. And I think you will find, you know, if you would go to the astronaut office right now and you would take a poll, there are 65, 70 astronauts in the office right now. How many of you wanted to go in space all your life? Half the hands would go up. And you'd say, okay, what about the rest of you? And they'd be like me. They'd say, never dreamed of it. I grew up in Columbia, South Carolina, segregated city in the South when I was a kid, when I was your age. Not much unlike stuff that still goes on here in the UK. You know, when I was here the last time, I think you all were celebrating the centennial of the end of slavery. You know, the United States was like that when I grew up. So in my high school, it was all black kids, all black teachers. The schools didn't get as much money as the other schools. So in my mind, I was never going to be able to be an astronaut. All astronauts were white, Anglo-Saxon, not Protestant, but they were almost all like 5'7", 5'8", because they were test pilots, as Maggie said. So I never dreamed of being an astronaut. The thing that it really pushed me to become an astronaut was meeting a guy who became my role model and my mentor, the late, great Dr. Ron McNair. Ron was like Maggie. Ron always dreamed of being an astronaut. Like me, he was African-American, grew up in a tiny little city called Lake City, South Carolina, about 42 miles from me. We didn't know each other, but I had gone through and made decisions in my life that eventually allowed me to become a test pilot. Ron came to the Naval Test Center for a reunion with some of his classmates in the astronaut program, asked me if I was going to apply for the space shuttle program. I said, no. He said, why not? I said, they'll never pick me. He looked at me and he said, that's the dumbest thing I ever heard in my life. He said, how do you know that they won't pick you if you don't ask? So no, I never dreamed of being an astronaut. Never dreamed of flying airplanes. In fact, told myself I would not fly airplanes. Definitely told myself I would not be a Marine. And so when I graduated from high school, I chose to go to the United States Naval Academy. When I graduated from the Naval Academy, I looked back at the one person who had most impressed me while I was there, and it was a Marine officer, and I said, okay, what the heck, I'm going to be a Marine. And so I went into the Marine Corps. I was going to be a ground officer, found I didn't like crawling around in the mud. The next best thing was listen to my wife. And my wife said, let's go to Pensacola, Florida, where you can learn to fly airplanes. So we went to Pensacola. I learned how to fly airplanes and fell in love with it. Question back there.
When you were on the spacecraft, did you feel like the difference when you left Earth?
Ooh, did I feel like what when I was on it?
Did you feel like the difference between Earth?
Oh, did I feel a difference like between here and there? The only difference you feel when you're in space, the significant difference, because inside the spacecraft, whether it's the International Space Station today or the shuttle back then, the only difference is the absence of gravity. You know, it's not 0 G. You're in a microgravity environment. But the atmosphere is 14.7 pounds per square inch, or however many millibars that is. But it's just like this room. Sound is the same. Smells are the same. The biggest difference is gravity is overcome. What causes us to float? Why do we float? Who knows? Yes? Why? Yell it out. Oh, you didn't. You weren't answering. Okay. Okay. You ever have a yo? You know what a yo-yo is? Okay. You know you get tired of spinning a yo-yo and you take it and put it over your head and twirl it around? What causes it to stay up there? Why doesn't it just hit you in the shoulder or something? What's it called? Centrifugal force. That's the exact same thing that happens to a spacecraft. We impart lots of energy to it, get it going really fast. In our case, we get going about 23,000 kilometers an hour. I mean, we're really hauling. And at that speed, it's called orbital velocity, the speed required to overcome gravity. And it's not fast enough to be pulled away from Earth's gravitational field the way it is when we go to the moon, but it's just enough to balance gravity out, and we float, because we become neutrally buoyant, if you will, and so we float. So that's the only difference in feeling between here and there. And another way it manifests itself is the fluids in your body seek equilibrium, which means big word. They just want to be the same throughout the body. So the lot of fluid that's normally in your legs when you're down here, it goes shoo. So 8.5 minutes after you lift off from the Kennedy Space Center launch pad and the vehicle stops being powered, you pop up against your straps, you're floating, and it feels like you have the world's worst head cold. Because lots of fluid is now in your head, we do something very simple. We go to the loo. So we go to the bathroom, we turn on the vacuum, and you take a little hose, and it's a unisex hose. You put it wherever you need to do it, and over the first couple of days, you urinate out about 2 liters of fluid, lots of fluid. You get rid of about 2 liters of fluid that you don't need, and so you stop having the headache again. Now, when you come back to Earth, you've got to replace that 2 liters. So we're gulping down stuff during the reentry. The hallmark of the space program today for all of us, for Europe, for Russia, for Japan, all of our partners, is the International Space Station up there. And I'll maybe talk a little bit more about it. This is another image of the International Space Station. This is somewhat unique because it has several Russian vehicles, a European autonomous transfer vehicle, cargo vehicle, a Japanese HTV cargo vehicle, and a shuttle, all berthed to it, docked to it at one time. So this is a very unique picture. This was actually, if I'm not mistaken, taken by Napoleon Nespoli, who was an Italian astronaut on his way home in a Soyuz. What do you notice about space? What's missing? Why? Somebody said stars. Why? Yeah. Well, now remember, you're in space now, looking out the window. How come there are no stars? And it's only during daylight. Our sun is so magnificent, it's so bright, that it just completely obliterates the ability of the human eye to detect stars. That's 45 minutes worth. The next 45 minutes, when you go into darkness, gazillions. I mean, the stars are brilliant. You would think that, okay, I can't see constellations anymore because I'm seeing too many stars. Constellations become even more brilliant, and they stand out even more. So it's an incredible, incredible exhibition of our universe when you go into darkness. Different advantages of daylight and darkness. We're now doing something different. Remember I told you we retired the space shuttle July a year ago. We're now relying on companies, private companies, American industry, hopefully partnered with foreign industry, to build spacecraft to take cargo and crew to space. These are just 3 examples. You've got the SpaceX Dragon over on your left. This is Cygnus, built by the European Space Agency in the middle originally. And then this is our heavy lift launch vehicle. We call it the SLS, Space Launch System, and it's going to carry a big crew module called Orion that'll look like an Apollo spacecraft, but that's just for deep space. That's for taking humans to an asteroid, hopefully in 2025, Mars in the 2030s, and then on beyond. So that's what we're looking forward to. Let me just give you 3 words of advice, all right? Not 3 words, 3 phrases of advice. Because you heard Maggie, you heard Dr. Richards, you heard Beth. All of us have talked about dreaming and doing big things. I'm going to get there. I got you. Okay? Give him a mic. First set of words, study hard. All this stuff that we talked about you can do, you've got to put something up here. So study really hard. You know, listen to your teachers in class. What should you study? Almost anything. But what you have to study, math, science, languages, history, writing, reading, you got to study everything. But the math and the science are critical. It doesn't matter what you want to do. You know, when you were listening to the music, that's math. It's a different number system. It's octaves. It's not decimal. So you need to study everything. So that's first thing. I show you this airplane because it's a NASA dream from a long, long time ago. The United States Marine Corps flies it now, and it's out at Farnborough if you get out there for the air show. It's called the MV-22 Osprey. It's a tilt-rotor aircraft. I use that as an example because to learn to fly this thing, you really have to study hard. So that's the Osprey. You've got to work really hard. And all I mean by that is focus when you're in the classroom. You know, listen to what the teacher's telling you. When you go out for football or for tennis or whatever else it is, or you go to the choir or you go to your band, focus on what the person's saying in there. Teachers and coaches always tell you all, you got to work if you want to win. You got to work if you want to be successful. You've got to work if you want to be successful in life. So work really hard. I show you this airplane. It's an experimental airplane that we don't even fly anymore called the X-29. It's very highly augmented with computers. It's inherently unstable, so if we turn the computers off, it would just flip over backwards. But we can fly it around, and it's very maneuverable because it's right on the ragged edge without the computers. And the final advice to you is don't be afraid of failure. You know, you cannot let the fear of failure, the fear of what somebody's going to say, somebody tell you you can't do something, you can't let that keep you from doing it. I use the shuttle in this image because after I flew my first flight to space, I came back. I mean, it was a dream come true. It was just the most awesome thing. 10 days later, we launched Challenger, and 73 seconds into the flight, it was gone. Gone. Just like that. And I asked myself, is this really what I want to do? It took me about a nanosecond. That's pretty quick, okay? It took me about a nanosecond to say, I came here to explore. I came here to make a difference. And I decided to stay in the space program and then flew 3 other times. You can't let the fear of failure keep you from doing something, you know? You can't let the fear of somebody ostracizing you or kidding you because you're too small, too big, too tall, too short, too black. Just do what you want to do. You know, don't let anybody else define you. Don't let anybody else tell you what you can or cannot do. There was a question up there. Yes?
Yeah, hi. I'd like to say it's amazing to be here. My question is, considering the sustainability international challenges that obviously NASA's facing and the confidence in your international partners, where do you see NASA in 20 years' time?
In 10 years' time?
10, 20 years.
Oh, man, we're looking 30 years out, to be quite honest. No, and I'll tell you what, in 10 years' time, some of those spacecraft I showed you, Cygnus for orbital, Dragon for SpaceX, we've got those are cargo vehicles, and they're getting ready to fly. Dragon has already flown. Dragon had an incredibly successful flight back in May. It was the first time ever a private company launched a spacecraft, found the International Space Station. The astronauts reached out, grabbed it, birthed it, which means they attached it to the International Space Station. Astronauts opened the hatch, went inside. It stayed there for 9 days. They put waste stuff on it and sent it back to Earth. And unlike every other cargo spacecraft like that in the past, it lived. It landed intact, that means together, so that it can be reused. That had never been done before, so that was incredible. Cygnus is getting ready to be flown by orbital. 10 years from now, hopefully you'll be seeing spacecraft that look similar to them, if not a winged vehicle, flying some of you to and from space. That's in 10 years' time. We really think we're about 4 or 5 years from private companies taking humans to space the way that only NASA could do before. 30 years from now, we will hopefully be on Mars. We will have been to an asteroid, at least one. And some of you are going to be running the space agency, whether it's the UK space agency or some other space agency somewhere, if you decide to migrate some other place in life. But that's what I see. Question there. Yes? Go ahead.
How long were you there for, like your journey?
Oh, how long was I in space?
Yeah, and did it feel long?
I'm a short-time person. I only flew on shuttle, and so my longest flight was 9 days. My shortest flight was 6 days. The difference between then and now, when an astronaut goes to space today, it's usually a 6-month stay. So mine was like a camping trip. You know, anybody could go tough it out for 9 days. You can't do that today. Today you live and work in space. And it's really important for you all to understand that. You probably have seen stuff in the papers or on the news that says, oh, NASA's walking away from human spaceflight. The United States is not involved in human spaceflight. You know, the UK made a decision some years ago that they didn't want to be involved in human spaceflight. I am hoping that the government's changing its mind right now. You have to be involved in human spaceflight. Every nation has to be involved in human spaceflight because it's in our DNA. You know, it's humans' destiny to explore and to go places we've never been before. And that's why I am convinced, because President Obama told me to make it happen, that in the 2030s, we're going to have humans on Mars. We cannot do it alone. Cannot do it alone. So it will be a joint venture of many nations working together. Question right here.
If you could swap places with someone for 24 hours, who would it be and why?
No one. I would not swap places with anyone. I wouldn't do anything in my life over again. I love my 3 granddaughters, and I would not do anything that would put having them at risk, having them in my life at risk. I don't care. You couldn't give me money. You couldn't give me anything. I love what I've done. My life is so rich. Don't have a lot of money, but that's why I say my life is so rich. You know, and you all, some of you will understand sometime. And most of you right now, all you dream about is money. You know, what job can I get so that I make a lot of money? Yeah, do I worry about money? I'm concerned that I have enough to pay bills and keep my wife and my family happy, but that's not what's most important to me. So I wouldn't trade places with anybody. I wouldn't. You know, I'd like to go back to space, but who knows? You know, you never know. Question? Yes? Yes? Do I believe they're extraterrestrials? I'm glad you said extraterrestrials and not aliens. Alien is not the correct word. The correct word is extraterrestrials. Things, life forms from other planets. I believe there is a possibility. I have no evidence whatsoever. Every one of my 4 flights, I was busy looking. You know, I wanted to see some sign that there is life in some form somewhere. And that's what I told you. If you stop and think about it, why do we do what we do? Why does NASA exist? Because we want to make life better for everybody on Earth, but because we wonder, are we by ourselves? You know, are we human beings on this one planet among billions of planets? I am a person of faith, okay? If I were here, I'd be an Anglican, but I'm an Episcopalian in the United States. Sometimes they jokingly call us whiskey-palians because unlike some religions, we drink. My faith tells me, you know, that my God is an omnipotent God or an omnipresent God. And that term omni means everywhere or all-powerful or all something. I mean, my faith says that whoever, whatever, whether it's him or her, that put all this stuff together, they didn't just put life here on one out of billions of planets. So I really do believe that there is a possibility of life somewhere else in this universe, and that's what I search for all the time. I want to know, are we alone, and, you know, where else is there life? So those are kind of questions. Back there, yes?
When you do, like, get back down to Earth, do you have to get used to stuff like the light or how to walk again?
Oh, when you come back?
Yeah.
Oh, great. When you come back from space. When you come back, it makes no difference how long you've been gone away. You do have to readapt. In the shuttle era, when I flew, it took a couple of days. You know, you just kind of do some deep knee bends and some other stuff, and your muscles were back. Your muscles knew how to respond to signals that your brain sent. And it takes a while. I mean, it doesn't just naturally respond because you've been in a microgravity environment. The thing that takes a long time, and it depends on how long you've been in space, is your inner ear, your balance mechanism, what we call the neurovestibular system. It goes to sleep. You know, with gravity missing, there is no reference for the human body on up and down other than vision. That's the only thing that tells you whether you're up and down. And since you're in space and you float and you do others, you don't care. You know, up and down is not important. The only way we even pay attention to orientation is so you know where to go get your food. You know, because some of that stuff's in the top drawer and some is in the bottom drawer. So you need to know what's up and down if you want good food, okay? Or if you need a diaper, you know, when you come home. Because when we put on the little launch and entry suits, we do wear a diaper, even now. You know, you don't, you know, it's embarrassing, but yeah. But the neurovestibular system takes anywhere from a couple of days to weeks, depending on how long one has been gone. But today we have a very good training regimen that puts people back with their physiologist, gets them back to what we call their baseline in terms of human performance. So we want them to go back to being as strong as they were when they left. Today's astronauts on the International Space Station, because of the training apparatus they have, the physical conditioning apparatus, and other things that we've learned over almost 12 years of flying in space now, they come back and they're pretty much as strong as they were when they left. So we don't have the problems. We're noticing a problem with vision. And that's something we really are going to have to understand before we talk about sending somebody to Mars for 8 months. Right here and then back up there.
Venus and Mars are meant to be Earth's sister planet. Is that true?
Are they meant to be? I don't know. You know, this creature, this thing that created all of this, only he or she knows. But what we do know that Venus and Mars and Mercury are terrestrial planets. They have soil. Or stuff like that. Venus is just too hot. You know, Venus is really hot. Its atmosphere is poisonous. So that's why we don't pay any attention to Venus in terms of, is there life? Most people have given up, said, no. We may change our mind one of these days. Mars is the perfect sister of Earth, if you want to say. A little bit smaller. Gravity's about, I guess, a sixth or a third or something like that. But we really think if there's a place in our solar system, Mars is probably the one. And it came from those other two because they are so much like Earth in size and everything else. Up there. I don't worry that we're going to. I do worry that we don't pay attention to the potential impact that we have on the environment because, you know, if we'll understand what's happening, then we can take actions to keep it, to counter it, to at least stop it. I don't know whether we can turn it around, but at least stop things the way they are today. I show you this picture because it's my favorite. Of all the pictures that I took in my 4 times in space, anybody recognize where that is? If I told you that this is, see this river? That's the Nile, going up to the Nile River Delta. That's the Red Sea. That's the Sinai Peninsula, the Gulf of Aqaba. Jordan is right over in here. Israel's up here. This is Western Saudi Arabia. If I had taken this picture seconds later, you would have seen Iran, Afghanistan, other places, because you're moving like 4 or 5 miles a second. Yes. Is it? Oh, this is the northeast corner of Africa, right there. Now, remember I told you I had done all this study because I wanted to see Nigeria and I wanted to see Namibia and I wanted to see Egypt and everything. You see any lines on there? That globe ain't got no lines. Pardon my English. I should have known better. You know, I'm an educated person. I should have known I wouldn't see lines between the countries, but I didn't. You know, I allowed myself to believe that when I got to space, I was going to see all these political divisions. They don't exist. This is among the most violent places in the world. And yet that's 250 miles away. That's all. No, that's wrong. That's 600 kilometers. That was on the mission on which we deployed the Hubble Space Telescope. So you're 600 kilometers away from Earth, looking down, no evidence of people, no political boundaries. It looks like this is absolutely breathtaking and beautiful. And what I seek to do the rest of my life is make it be like that. And that means we have to do stuff. We have to quit hating each other. We have to keep making differences, creating differences. You just can't do that. You know, that's the way God created it in my world. And it is peaceful and unified. I mean, when we decide we're going to do things, it is absolutely incredible. The International Space Station, we built that with the former Soviet Union, Japan. Just think of those 2 countries and our relationship with them. And now we are partners, and partners forever in all probability. Question right here. Oh, when a satellite's doing its mission, what happens to it? Depending on where it's going and what its mission is, a lot of our satellites just orbit Earth. The climate satellites, the weather satellites, satellites that we use in what we call Earth science, trying to find out what's our atmosphere like, what are the oceans like, how much salt in the oceans. We did a joint satellite effort with the country of Argentina. Argentina was the big country, Brazil, I think the United States, the UK, a lot of European nations did a satellite called Aquarius SAC-D. It launched last year. Aquarius has now mapped the oceans of the world so that we know the salt content in the oceans of the world, I mean, like down to a teaspoon. That's incredible. Those satellites orbit Earth, do their thing with their instruments, and then at some point they die. They run out of life. Either the batteries run out or the solar cells get old. And then today we have a planned deorbit for them. They come back, they burn up, and we try to put them in the ocean somewhere. Some of them that are up much higher, we can move into what we call a parking orbit. We'll move them up much, much higher, so they're going to be there for hundreds of years and not deorbit and cause damage to the International Space Station or something else. So different things happen depending on what the satellite is. Almost all of them are working 24 hours a day doing something, even when they're not over, because satellites go around, most go around Earth. Some are called geostationary, so they're like way out, and they appear to be stable over one part of Earth. The reason they look like that is because their speed is such that it's going around Earth at the same speed that Earth is rotating on its axis. So they appear to just sit there. When you look at some television satellites and stuff are just in geosynchronous orbit, so they just sit there. Yes, and then back up there.
Do you think there could be life like this, exactly like this in another part?
Do I think there could be life like this, like us, in other parts of the universe? Do I think? I don't know. I hope so, but I don't know. The one thing I want all of you to understand, because some of you are going to go out here and you're going to be among the people that are going to find this life one day. When it doesn't look like us, it's not bad. Okay? If it looks like an alien, like from a movie, don't just assume it's bad just because it looks bad. It's like we were trying to show you, what does a scientist look like? Don't just assume because somebody's muscular or somebody's got a football or a tennis racket that they're not a scientist. That's just, so give them a chance, all right? Be open when you meet the first life forms that are extraterrestrials. Way back up there with the mic. Yes. That's Hubble, by the way. Yes.
What did you do before you were the administrator of NASA?
What did I do before I was the administrator of NASA? Well, I was trying to retire. I was trying to go on pension, and I flunked. I failed retirement. My wife and I, we opened a small company, a private consulting firm, so she was the boss and I was the worker. And I travel around the world consulting on military issues, on issues pertaining to aviation and space and leadership. So that's what I did. I did that for about 6 years, and then President Obama, he didn't really call, but someone called for the president and said, hey, can you come to Washington and meet the president? And I said, for what? And they said, well, we can't tell you. I said, then I can't come. Because the president is too busy a guy, and I don't want him wasting his time, talking to somebody like me. I would love to meet the president, but tell me what I'm coming for or something. So they finally said, well, he wants to ask you some questions about our space program. And so I went to Washington, D.C., and it took me a couple of days, and then I met with the president for about 15 minutes. I was blown away. I mean, I was just mesmerized by this guy who is so charismatic, so smart. He's thinking about all kinds of things all the time. He's just incredible. And he said, whoever becomes the new NASA administrator, I want to see him inspire our kids again to want to explore. We've got to get back to where we used to be in science and technology. So we've got to help them understand they've got to study math and science and stuff like that. And we just need to reshape the agency so that it does more things that are responsive to the needs of people on Earth. And that sounded good to me, so I said, okay. And that's how I got my job. How do you make sure it doesn't expire? We actually, for a station, we don't fly the same kind of foods that we flew on the space shuttle. On space shuttle, we partially cook food, dehydrate it, take the water out of it so that it can be kept in small containers for long periods of time. Like that's a container. There's a couple over there. This is a food tray, for example. That's my third flight in space on Atlantis on a mission called ATLAS, the Atmospheric Laboratory for Applications in Science. But we irradiate the food, you know, to keep bacteria out. Meats we put in a foil wrapper. It's irradiated, so they can last for a long, long time. You don't add the water until you're ready to eat it. When you rehydrate it, then it comes to life for all intents and purposes. We eat jumbo shrimp, you know, greens, beans, peas, all kinds of meats, fish, everything else up there. Yes?
What do you say to conspiracy theorists who say that American men did not go to the moon and that it was actually a fake?
I tell them, look, I have several friends, Neil Armstrong, Buzz Aldrin, Charlie Duke, John Young, who I trust and I believe. I know I've been to space, so I've seen how difficult it was to get there. I've seen what it's like, so I can logically accept the fact that they, in fact, walked on the moon. And then I don't, like I told you, don't be afraid of failure. I don't waste a lot of time trying to convince people. Like for the young ladies here, when you go to your first job, don't spend a lot of time trying to convince somebody that you belong there, okay? Just do your job, do it well, and they'll either come around and will accept you, or in a while you'll be their boss. So my philosophy is, if somebody dislikes you because you're female or you're black or something else, you're not going to change their minds by anything you say. You will affect them and change their minds by what you do and how well you do it. So that's all you can do. And we're going to have maybe 2 more questions because I've been talking too long. I'm going to show you, let me see. There's the loo in the shuttle. And Maggie, you did a great job explaining it, so I don't have to explain it anymore. But it is really important that you use the little things that Maggie talked about, because you can float away and then it's ugly, okay? So you don't want to do that. That's called a launch and entry suit. That's what we wore in the shuttle era to protect us if something happened like happened on with Challenger. We thought that that might provide some protection for a crew if you lost the vehicle. Waving your hand, yes. Go ahead.
Hiya. I'm from Uprising, and we're currently doing a social action campaign aimed at decreasing unemployment for youth. And I was just wondering how today, and using STEM, could actually, how you could use it to decrease unemployment. I've read somewhere on the NASA website that you've spoken about how America needs a competitive edge using STEM. So I was just wondering how you would actually use science, technology, engineering, and mathematical
I think if you just talk to some of the companies here in the UK, they will tell you there are jobs to be had. They don't have the people who have the requisite skills and knowledge to fill those jobs. A lot of things, yeah, I mean, we have all kinds of jobs. There's manual labor, there's administrative work, then there's high-end jobs, engineering, design, whether it's vehicles or software stuff. You've got to have a little bit more education than the average bear. And so that's why I think all of us have said, study hard, work really hard, don't be afraid of failure, and you will find the jobs. The jobs will come if you have an education in science, engineering, or math. We've got to do that. We have some other things in the United States. We've got to convince companies to start hiring people the way they used to and holding off. But that's a love of money, my belief. They don't want to spend money on jobs, so they keep it and put it in the bank, all right? That's the shuttle landing, and I'm going to let you read that, and I'll tell you about it. Yes, right in here, in the middle. It will, yeah. Yes?
How did you sleep in space?
How did I sleep? Really, really well. When you're in space, again, remember you're floating, so we float into a sleep restraint. It's a very lightweight sleeping bag. Zip yourself in. I always just tied the bottom of mine to the rudder pedal up on the flight deck of my seat so I could float up on the flight deck with a camera, and if I wanted, because as you go around Earth, orbital mechanics means that if you launched in the daytime somewhere, that part of the world that was in daylight when you launched is going to be in daylight most of the time you're flying. If you want to see a place that was in darkness when you launched, then you've got to be awake in your sleep period. And so that's what I would do. Like I wanted to see places like Vietnam, places I'd been in different times of my life, and so they were in darkness when I launched, so I had to get up in the middle of the night and take pictures to do that. So that's how you sleep, and it's really good. I know you, I apologize. Okay, you can put your hands down. Do? Okay. Story, real quick. The young man, this is a quote from a 12-year-old kid who was born in a place called KwaZulu-Natal, South Africa. His name was Nkosi Johnson. I see somebody shaking. So some of you may have heard this story. Nkosi was born with AIDS. So he was destined to die at birth. His mother had AIDS. She knew she was going to die, so she had a young white woman that she said, look, this is my son Nkosi. Please take him and raise him, after I die. And this woman was named Gail Johnson. She took Nkosi, and his mother died shortly thereafter. But everybody that ever knew Nkosi said he was an exceptional kid, because as soon as he could speak, he was telling people to do things for the village. We need to do this. He was taking care of other people. And that's what he and his mother, his stepmother, Gail Johnson, did. They traveled all over their village, then they traveled all over South Africa, then all over the African continent, then all over the world, crusading against AIDS to try to solve the problem of AIDS, but also crusading for temperance and moderation and tolerance. And an American writer named Jim Wooten heard of this kid, and he said, I got to go meet him. So he flew over to South Africa. He sat down with Nkosi. He said, Nkosi, why do you do what you do? And Nkosi looked at him and he said, you know, I may be black, I may be small, I may be poor, I may have AIDS, but in this world we're all the same. So Jim Wooten wrote a book about Nkosi Johnson, a biography called We're All the Same. Came back to the United States. Several months later, got another call, said, hey, Nkosi is not going to do well. He is dying. He is not going to live very much longer. Flew back to South Africa, sat at Nkosi's bedside. The kid was 12 years old. Jim said he weighed less than 20 pounds, skin and bones, this beautiful black face with sores all over it and everything, and this beautiful set of white, shiny teeth just out there, and he had a big smile on his face. And he said, Nkosi, I don't get it. He said, you know, you're still telling people to do stuff for other people. You're still happy. You're going to die. He said, Nkosi said, yep. He said, you could die today. He said, yep. He said, look, I give. Just quit. What makes you tick? And he said, Nkosi looked up at him and said, you do all you can with what you have in the time that you have in the place that you are. That's all Dr. Richards has been telling you. That's all Maggie's been telling you. You know, that's what Beth's trying to tell you in her songs. You all have the world is yours. You can make it different. You can make it be like I saw it from space. But it takes work and it takes time, and you've got to study and work hard, and don't let anybody tell you what you can or cannot do. So God bless all of you, and thank you very much. Thank you. Thank you. Thanks very much.
Okay, right. Obviously, some people I know have to leave very shortly, and we've got a final musical interlude by Beth Chapman. Before we do, I'd just like to welcome Charlena from the US Embassy, who's just got a few things to say, which could well be to your benefit.
Hi guys, I know some of you guys are familiar faces, some are new, so hopefully this is not the first time the Embassy will have an event with all of you guys in attendance. Just a housekeeping thing, you guys have pink sheets in front of you. Fill them out, because the incentive is when you leave out there's a packet waiting for you that you can get in exchange for your pink sheet that includes, among many things, a autographed photo by Charlie himself.
Yep.
So I'm thinking you're gonna want that. So I know some of you guys are falling asleep. I know it's a long day. It's fine, no problem. Just scratch off the drawing part on the pink sheet and actually write some comments, because we will give you a nice packet in exchange. So thank you very much for your patience. Beth will be singing one more song.
Now, like whilst Beth is, I can take you to great.
Farther, Adam.
We're going to do that. At
This
the
is
very
called
end.
You Can See the Blues.
Quickly, and then I'll be back.
The electromagnetic spectrum is making a lot of waves. Go from radio to energetic gamma rays, but you can see the blues and all the visible hues, the colors of the rainbow, the energies that they use. see a single x-ray, baby, but you can surely see the blue. Well, they tell me Roy G. Biv is the color of sun's light. When you put them all together, somehow it comes out white. You can see the blues and all the visible hues, red, orange, yellow, and green, indigo and violet too. Can't see a thing in infrared, but you can surely see the blues. The stars of various colors shining up in the sky. Everything, the wavelength is how they're classified. You can see their other energies too. The secret in the starlight and the photons give us clues. You can measure all the microwaves. You can surely see the blues. If you want some radiation, babe, you can surely see the blues. Thank you, guys. Charlie Bolden.
Excellent. Once again, let's give a big hand for Beth and also Charles, also Maggie and all the speakers. I think we have one more thing which we have to do, which I believe a representative from NASA will be here to say a few words to the college and to the audience. I think they're on the way. So, and I also want to thank all you guys for your patience as well. But there's one last thing which I think we're about to do. By the way, did you all enjoy that? Yes. Excellent. Are you feeling suitably inspired? Yes. Great. And will I see some of you at least in a few years' time as students? Come on, you can believe. You can believe. Okay, sorry, we are back now. And I'm back with Charles Bolden, the NASA administrator. And we've got the final thing to do, which I think Charles is going to say a few words.
What I want to do is I want to make this presentation to the university on behalf of all of us from NASA. The American flag, the British flag, and the patch actually flew on the space shuttle, so they have been to space. This is the International Space Station, an astronaut doing a spacewalk, and some other images of Earth. If you decide that you're going to come here to the university, then this will be you'll be a piece of this. This will belong to you as a student. But if you'd accept this on behalf of the university, I appreciate it.
Thank you very much.